Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the determination of sodium by a Mohr titration. Okay, so in the previous lecture we already discussed the determination of sodium by a ion selective electrode. Ion selective electrode. And in the same lecture I already told you what is the importance of this sodium and why we have to determine it. Okay, so if you have any query related to this, go and watch the video determination of sodium by a ion selective electrode, and the introduction part are also covered in that lecture. Now here we are going to see the objective of this experiment. What we have to do, we have to determine the sodium content by using a Mohr titration, and also we have to determine the chloride content. Okay, so here we are taking a food as a sample. So determine the sodium content of various food using a Mohr titration method to measure a chloride content. Okay, so again we take a potato chips, okay, either cheese, okay, it depends upon the product. Now the next one is your principle. The Mohr titration is a direct titration method to quantitate chloride ion, and then after that we have to calculate the sodium ion. Okay, so see, this Mohr titration are what? It is a direct titration method, and this method is used to quantitate the chloride ion, and with the help of this chloride ion we have to calculate the sodium ion. Okay, the chloride ion containing sample solution is treated with a standard solution of silver nitrate. Okay, what we have to do, we take a sample. Suppose that this is our potato chips. Okay, now this potato chips contain a what? This contain a chloride. Okay, and what we have to do, we titrate this solution to a standard solution in which standard solution of silver nitrate. After silver from a silver nitrate has complex with all the available chloride in a sample, what this silver nitrate do, this silver nitrate form a bond with this chloride which are already available into a sample. Then silver react with chromat and has been added to the sample to form a orange color solid silver chromate. Okay, the volume of silver used to react with the chloride is used to calculate the sodium content of the sample. Okay, this is a principle of determination of sodium with the help of Mohr titration. Now the next one is your chemical. Here the list of the chemical that used into this experiment. The first one is your potassium chloride, that is your KCl. Okay, 7447-40-7, and the hazard related to this chemical are what? They are irritant in nature. Now the next one is your potassium chromate. Okay, 7789006 case. Hazard related to this experiment, this chemical are what? They are toxic and it is dangerous for the environment. Now the next one is your silver nitrate, that is 7761-88-8. It is what? It is corrosive, it also dangerous for a environment. So we are using three chemicals. One is your potassium chloride, potassium chromate, and silver nitrate, and all these three chemicals have a hazard, like if they either they are irritant, either they cause toxic, either they are dangerous for our environment and corrosive in nature. So when we using this chemical, we have to take a care during the use of these type of chemical. Now the next one is your reagent. We use three reagent in this solution, in this experiment. One is your potassium chloride and potassium chromate and sodium nitrate solution. Okay, so how we prepare this solution, you go and see the solution preparation video which are related to this topic. Now the next one is your hazard precaution and waste disposal. We all know that we are using a hazardous chemical. So when we are using the hazardous chemical, we have to follow all the laboratory practices, like we have to wear a glove, we have to wear a lab coat, we have to wear a glasses, and we have to follow all the instruction which are given by a lab assistant, and all of this also we have to follow a or protocol which are given by the institution, and we have to also take care our environmental health. We all know that this potassium chromate are what they are, they cause a skin reaction. So when we are using this potassium chromate, we have to take a care. Now see what is written in a slide. Wear a gloves and safety glasses at all time and use a good laboratory technique. Potassium chromate may cause a serious skin sensitive reaction. Okay. What? Potassium chromate. Okay. And this silver nitrate or a solution of silver salt can also result in a dark brown stain, which is caused by a photo decomposition of the salt to a metallic silver. Potassium chromate and silver nitrate must be disposed of a hazardous waste. Okay. What? Potassium chromate and silver nitrate both are considered as a hazardous waste. So when we are disposing it, we have to dispose it in a separate. And other waste are what other waste what we have to do, we rinse out with the help of water, and all of the above we have also follow up good laboratory practices which are outlined by our environmental health and the safety protocol which are given by the institution. Okay, now the next one is your material used for this experiment. We required a 6 beaker of 250 ml, down bottle of 500 ml, burette of 25 ml, 3 milliliter flask of 125 ml, okay, 4 milliliter flask of 250 ml, and the food product. Here we required a sample like cottage cheese or around 30 gram, potato chips around 15 gram, sports drink around 15 ml, okay. Then we required a funnel, glass wool, graduated cylinder of 25 ml, magnetic stir bar, which are fit to one, either we have 125 ml or either we have 250 ml flask, pipette bulb or a pump, spatula, weighing paper and board, and volumetric pipette of 1 ml. Now the next one is your equipment required for this experiment. We required three equipments. One is your analytical balance, then hot plate, then magnetic stir plate. Okay, now the procedure. The first procedure are divided into two categories. One is your sterilization of 0.1 molar of sodium nitrate. For this, what we have to do, we take a 400 ml of 0.1 molar of silver nitrate solution into a brown bottle. Then we have to sterilize this solution by titrating this to a food sample. So we fill this AgNO3, that is silver nitrate, into a burette. Okay. Then after that, we have to prepare a primary standard of potassium chloride whose molecular weight is 74.55 and solution in a triplicate, and according to weight to 4 decimal places around 100 places about 100 milligram of KCl into a 3 aluminum flask of 125 ml. Then we dissolve this KCl into our deionized distilled water, and the volume of deionized distilled water is around 25 ml. Then after that, we add our K2CrO4 solution. Okay, it is what? It is a potassium chromate, 2 to 3 drop. And when we adding this potassium chromate, we have to take a care, because this potassium chromate may cause a serious skin sensitivity reaction. Then we put it into a magnetic stir bar, okay, and place a beaker on a magnetic stir plate and below the burette for a titration. Then with the help of silver nitrate, we fill it into a burette and titrate it with the KCl solution to the appearance of the first permanent pale pink or orange color. This pale pink or a orange color are what? They are a end point of the titration. Now you have to note one thing, you will get a white precipitation, then green, and then after that you get a pink orange color. Okay, when we are titrating it, first what we have to get, we get a white precipitate. Then this white precipitate are converted into a green color, and this green color are converted into a pink orange color. Then the end point is is due to the formation of Ag2CrO4. Okay, this is a reason for a pink color. Okay, the solution must be vigorously stirred when we are adding the AgNO3 solution so that it will avoid the erroneous in a result. Now the next one is that we have to record the volume of sodium nitrate, and then we have to calculate the molarity of the sodium nitrate. This formula, by using this formula, uh, that is your uh, G. Okay, this is your formula which we have to calculate molarity of the AgNO3. Then we label the bottle of with the AgNO3 mark, and then also we have to mention our name and molarity of the solution. Now come to the next slide. Now the next is samples by a Mohr titration. Okay, so the first sample is what we have a cottage cheese. So we weigh a 10 gram of cottage cheese, and this 10 gram of cottage cheese weigh in a triplicate. Suppose that we take a beaker of 250 ml. Okay, this is our 3 beakers of 250 ml, and in each beaker we add 10 gram of this cottage cheese. Okay, then after that we add 50 ml of warm deionized water, and the temperature of this water is around 50 to 55 degrees Celsius. And when we adding this in this warm water in each of the beaker, then after that we mix this. Suppose that here we add 15 ml, here we add 15 ml, and here also we add 15 ml. Okay, now we stir it with the either with the glass rod or either with the spatula. Then after that what we have to do, we have to add our 250 ml of deionized water again to each of the beaker until the sample is dispersed. Then quantitatively transfer each solution to a 100 ml of volumetric flask, rinsing beaker and magnetic stir bar with the deionized water several times. Dilute to a volume with a deionized water. Then after adding this 25 ml of deionized water, what we have to do, we transfer each solution, like this is first solution, this is second, this is third. Now what we have to do, we transfer each solution into a volumetric flask of 100 ml. Now after that we filter each solution through a glass wool. Okay, then we transfer 50 ml of solution into a 250 ml of Iremilian flask. Then we add potassium chromate as an indicator in each flask of 50 ml. Okay, and the amount of this potassium chromate are what are 1 ml. Then after that what we have to do, we filter it and we titrate it against with the sterilized 0.1 normal of AgNO3, and the end point will be a red brown color. Okay, and this red brown color should be persist at least for 30 seconds. Then we have to record the volume of titrant which are used. Okay, like titrant value, initial value minus final value. Okay, so this is how we titrate the cottage cheese. Now the next one is your potato chips. Okay, so again what we have to do, again we take a 3 beakers, and in each beaker what we have to do, we add a 5 gram of potato chips. This is 5 gram, this is 5 gram, and this is 5 gram. Suppose that this is A, this is B, this is C. Then in each of the beaker we added a 95 ml of boiling deionized water. Then we stir the mixture continuously for 30 seconds and just put it for a 1 minute. And after 1 minute, we again stir the solution for a 30 seconds and then leave it at a room temperature for cool down. Then we filter the solution with the help of glass wool and transfer 50 ml of solution into a 250 ml of Iremilian flask. Then in Iremilian flask, what we have to do, we add potassium chromate as an indicator, and uh, in each solution, and the volume of potassium chromate is around 1 ml. Okay, after that what we have to do, we filtrate it. Okay, then we titrate it against a standardized 0.1 normal of AgNO3, and the endpoint again, it is what? It is a pale red color. This is what? This is your endpoint. And this endpoint should be persist at least for 30 seconds, and then you have to record the volume of titrate used. Now the next one is your soft drink. Again, you have to take a 6 beaker. In each beaker, you have to add 5 ml of sport drink. Okay, here he is performing a duplicate. You can perform it and triplicate. Now you have to add 95 ml of boiling deionized distilled water in each of the beaker, and you have to stir it for a 30 second and wait for a 1 minute, and again you have to stir for a 30 second. Now you have to transfer 50 ml of solution into a aeromelial flask. Okay, now in a aeromelial flask, you have to add 1 ml of potassium chromate as an indicator, and you have to take 50 ml of prepared sample. Now you have to titrate it against a sterilized 0.1 molar of AgNO3, and the endpoint will be what? Will be a pale red brown color, and it should be persist for a 30 second, and then you have to record the volume of titrate used. Now the next one is your data and calculation. After procedure, what we have to do, we have to calculate the data. Now for calculation of the data, calculate the chloride content and the sodium content of each replicated sample. Then you have to calculate the mean and standard deviation for each type of sample. Then after that, you have to express the value in terms of percentage, like weight by volume for the cottage cheese and potato chips, and percentage volume by volume for a sport drink. See, cottage cheese and potato chip, one thing is a solid. That's why we are expressing in terms of weight by volume, but in a sport drinks, both are in liquid. That's why we are expressing in volume by volume. Now you have to note that answer must be multiplied by the dilution factor. Now here we have to calculate the chloride concentration. Chloride percentage is equal to ml of AgNO3 divided by gram of sample in gram, then molarity of the AgNO3, then volume in liter, then 35.5 gram of chloride, volume of molarity of NaCl 1 liter, multiply by 1000 ml, multiply by 100, multiply by dilution factor, and the percentage of sodium chloride is calculated by ml of AgNO3 divided by sample in gram, then AgNO3 molarity, then liter, then multiply by 58.5 divided by molarity of NaCl, then multiply by 1 liter divided by 1000 ml, multiply by 100, multiply by dilution factor. Okay, this is how we calculate the percentage of chloride and percentage of sodium chloride. Then this is a table for cottage cheese, potato chips, and sport drinks. Here a burette start, you have to put down a burette start reading and burette end reading, and then you have to calculate the volume of AgNO3 used. Okay, then with the help of this, you have to calculate the percentage of chloride and percentage of sodium chloride. Then you have to take a mean and you have to take a mean and standard deviation. So this is all about how we determine the sodium with the help of this Mohr titration. You can follow the ITLS Academy on Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide. You can also visit our website, that is www.itlsacademy.com, and if you have any query, just let us know in a comment box. Thank you for watching. Please like, share, and subscribe. Thank you.